My team's original goal was to gain better understanding of cystic fibrosis and help to suggest which treatments would be best to use based on a mathematical model. Cystic fibrosis is caused by genetic mutation. There are 70,000 known cases. To achieve our goal, we used a mathematical model developed by Dr. Voit, a member of the BME faculty at Georgia Tech. We started with a series of initial conditions which are close to the steady-state positions of the model for a healthy individual. We then came up with a series of multipliers which we derived from the relevant literature which simulate using a treatment on a CF patient. There are a number of different treatments used to treat cystic fibrosis. We wanted to determine the effect of changing different parameters on the cystic fibrosis model. We did this using Matlab. This allowed us to focus on specific treatments. We discovered that a major problem in the treatment of cystic fibrosis is patient noncompliance, which exists at rates of up to 40%. So we thought, what if the patient could be shown the importance of treatment? To do this, we decided to use Matlab. When the CF modeling suite is opened, you're taken to a home page. From here, you can go to the Exploring CF page. On the Exploring CF page, you can change the time range, and you can select whether the patient has CF or not. You can then run a simulation. On the right side, you see some important info about the simulation itself. You can then select the parameters to graph and click Graph. You'll get a nice graph that pops up along with a legend. Now let's see what happens for a patient that does have CF. We run the simulation again, and we tell it to graph again. And right away you can see that there is definitely a difference there with the bacteria. Now let's see what happens if we apply a treatment. In this case, we're going to use tobramycin, an antibiotic. We click on the buttons, and it automatically puts in the correct multipliers and affects the simulation. We run the simulation again, and we tell it to graph. Right away, you can see the enormous difference that the treatment has. We can also save both the graph and data for later. Now, what if we want to compare two different situations? Well, that's in the suite as well. You can compare two situations. So we'll have situation 1 and 2. They'll both have CF. And this will be to help a patient understand the importance of their treatment. We're going to give one of the patients treatment and one of them not. And we'll run the simulation. Now it'll run the first simulation and then the second one, and we'll select which parameters we want to graph again. And we graph them. When we graph them, we get 3 graphs. We get a graph for each situation, which you can just put side by side to easily see the difference between the two situations. And then if you scale the situation down to a more accurate scale, then you can see the true difference between the two situations. You can also look at a comparison graph, which subtracts one situation from the other and clearly shows the improvement in bacteria for the treatment. The data and graphs can all be saved, of course. Software was, of course, developed using the Matlab IDE, and it was also supplemented by using the guide system to develop the graphical portions. The model is calculated in real time as the user runs the simulation using MATLAB's numerical approximation capability. Using the MATLAB environment and the awesome documentation available from MathWorks, along with the forums provided by MathWorks, this software was actually relatively easy to write, and learning new things to write the software was really very, very friendly. The source code for this project, as well as compiled executable versions of the software, are available at tinyurl.com/CF modeling. If you have any questions or comments, please leave them in the comments section below, and I'll be sure to get